Hello, everybody. How are you? And welcome back to the study of waves. In the last lecture, we saw that velocity of transverse wave on a string v is equal to under root t by m, whereas t is tension in the string and m is mass per unit length of the string. Mass per unit length of the string. Means that velocity of transverse waves depends upon two factors. Which are those two factors? Tension means the restoring force. The velocity of transverse wave depends upon the restoring force, and it depends upon the inertial property of the medium. It depends upon inertial property. Mass is inertia of the medium. So it depends upon restoring force and inertial property of the medium. So V is equal to under root T by M. This is the velocity of transverse wave on a string. तर string वरती wave create होण्यासाठी the string should be stretch केलेली असली पाहिजे string. There should be tension in the string. जर स्ट्रिंग मध्ये टेन्शन नाहीये, स्ट्रेच केलेली नाहीये, लूज अशी स्ट्रिंग आहे, वेव त्याच्यावरती जनरेट होणार नाही. Because when t is equal to 0, velocity of the wave will be equal to 0, means no wave will be produced on the string. So for the propagation of transverse wave on a string, the string must be stretched. There must be tension in the string. So this is the velocity of a transverse wave. What about longitudinal wave? For velocity of longitudinal wave, first of all, the velocity of longitudinal wave is minimum in gases. Velocity of longitudinal wave is minimum in gases. Longitudinal waves can travel through solids, liquids, as well as gases. Transverse wave only through solids. Longitudinal wave through solids, liquids, as well as gases. And velocity of a longitudinal wave is minimum in gas. त्याच्यापेक्षा जास्त velocity असते longitudinal wave in liquids, and the velocity of longitudinal wave is maximum in solids. Why it is so? Newton, he derived the formula for velocity of longitudinal waves. He said that velocity of a longitudinal wave v is under root E by rho. Velocity of longitudinal wave is under root E by rho, whereas E is elasticity of the medium. V is elasticity of the medium. E is elasticity of the medium, and rho is density of the medium. So velocity of longitudinal waves depends upon two factors. Elasticity of the medium means modulus of elasticity of the medium, and density of the medium. And modulus of elasticity is more for solids. Therefore, velocity is more in solids, less in liquids and gases. So according to Newton, velocity of longitudinal waves v is equal to under root E by rho. It depends upon elasticity of the medium, means modulus of elasticity, and it depends upon density of the medium. Then from that, Newton formulated the velocity of sound in air. This is general velocity of longitudinal wave in any medium. This is velocity of longitudinal wave in any medium. Specifically for velocity of sound in air, Newton said that it will be v equal to under root p by rho. The velocity of sound, not any longitudinal wave, velocity of sound in air specifically, it is given by V is equal to under root P by rho. This P is pressure of air, means atmospheric pressure, and rho is density of air. Means what Newton said, E is replaced by P, means elasticity of the medium is pressure. Elasticity of air is equal to atmospheric pressure. Elasticity of medium or elasticity of gas, air is a gas, is equal to its pressure. Why? Because Newton says that the elasticity of air is equal to pressure. For that, what Newton assumed, when sound travels through air or sound travels through any gas, Newton says that the temperature of that gas remains constant. टेम्परेचर चेंज होत नाही. जेव्हा साऊंड वेव्ह गॅस मधून जाते तर त्या गॅसचा किंवा एअरचा टेम्परेचर चेंज होत नाही. दॅट्स व्हॉट न्यूटन सेज. When sound wave travels through a gas, the temperature of the gas remains constant. Means the process is isothermal process. कोणता process? Isothermal process. You know what is isothermal process? The process in which temperature remains constant is called isothermal process. The process in which temperature remains constant is isothermal process. And according to Newton, when sound wave travels through a gas, the temperature remains constant. Means this process is isothermal process. And isothermal modulus, bulk modulus of air, isothermal elasticity or isothermal bulk modulus of air is equal to its pressure. The isothermal bulk modulus of air or isothermal elasticity of air is equal to pressure of air. So Newton replaced E by P. Elasticity, bulk modulus जागी त्याने काय घेतलं? Pressure upon rho as it is. So V is equal to under root P by rho. That is Newton's formula for velocity of sound in air. So according to Newton, velocity of sound in air is under root P by rho. P is pressure of air or pressure of the gas, and rho is density of air or density of that gas. He replaced E by P. And why he did that? Because according to him, the process is isothermal. When sound wave travels through air, there is no change in temperature. So it is isothermal process, and isothermal bulk modulus of a gas is equal to its pressure. So V is equal to under root P by rho. This is Newton's formula for velocity of sound in air or velocity of sound in any gas. If you put the values in this formula, suppose at NTP, normal temperature and pressure, pressure equal to 1 atmosphere, means 1.013 into 10 raised to 5. You know what is 1 atmosphere? 1.013 into 10 raised to 5 Newton per meter square. Pressure तेवढा घेतला. Density of air at NTP, that is 1.29 something. ही घेतली. तर ही velocity येते 279.9 meter per second. By using Newton's formula, if you find out velocity of sound in air at NTP, it comes out to 279.9 meter per second. But actual velocity of sound in air at NTP is 332 meter per second, approximately 332 meter per second. Means there is a huge difference. न्यूटन्स फॉर्म्युला प्रमाणे जर आपण वेलोसिटी काढली तर ती येते 279.9 मीटर पर सेकंड आणि ऍक्च्युअली ती असते 332 मीटर पर सेकंड. मीन्स देयर इज सम एरर or you can say there is a mistake in Newton's formula which was corrected by Laplace. So Newton's formula gives you this velocity of sound. Actually it is this much. This mistake or this error was eliminated by Laplace, and it is called Laplace's correction. Laplace's correction. What is that Laplace's correction? Newton had said that when sound wave travels through a gas, the process is isothermal according to Newton. And therefore, Newton took E is equal to P. Isothermal bulk modulus of gas is equal to its pressure. What Laplace says, he says that when sound wave travels through a gas, sound wave is a longitudinal wave. There are compressions and rarefactions. And these compressions and rarefactions are very fast. Compression, rarefaction, very, very fast. Frequency is very high. So Laplace says that when there is sudden compression, what will happen? The temperature in that region will rise, isn't it? Current suddenly compress झाल्यावर heat generate will, when there is sudden compression, heat will be generated, and the process is so rapid, so fast, that heat energy cannot go out. It cannot be dissipated to the surroundings. Heat energy is not dissipated to the surroundings. Therefore, the temperature there, it will rise. And when there is sudden rarefaction जर झालं तर काय will? Heat will be taken out so that temperature will fall. बाहेरून आतमध्ये हीट येण्यासाठी तेवढा वेळ नाहीये कारण खूप फास्ट rarefaction झालं. Means what will happen? The temperature there will fall. Such process is called adiabatic process. अशा प्रोसेसला आपण काय म्हणतो? Adiabatic process. You will learn the details of this in heat section as well as in chemistry. So what is adiabatic process? The process in which heat is neither allowed to enter or leave the system. Heat is neither allowed to enter or leave the system is called adiabatic process. So Laplace says that as there are sudden compressions and rarefactions, बाहेरून heat आतमध्ये येऊ शकत नाही, आतमधली heat बाहेर जाऊ शकत नाही. Heat is neither allowed to enter or leave the system, leave that wave. Therefore, the process is adiabatic. It is not isothermal according to Laplace. So according to Newton, when sound wave travels through a gas, the process is isothermal. And according to Laplace, the process is adiabatic. Heat is neither allowed to enter or leave the system. The temperature changes. And adiabatic bulk modulus of a gas equal to असतं gamma P. Isothermal bulk modulus of a gas is equal to pressure, and adiabatic bulk modulus of a gas is equal to gamma P, whereas this gamma is Cp upon Cv, ratio of specific heats. Specific heat at constant pressure upon specific heat at constant volume. We'll learn the details in heat section again. So according to Laplace, the bulk modulus should not be equal to P, it should be equal to gamma P, whereas gamma is ratio of specific heats, Cp upon Cv. So Laplace's correction says that V is equal to under root, not P, but gamma P by rho. So Laplace's correction says that velocity of sound in a gas is equal to under root gamma P by rho, whereas gamma is ratio of specific heats of air, P is pressure of air, and gamma is density of air. And suppose if it is another gas, it can be air or it can be another gas, then gamma will be ratio of specific heats of that gas, P will be pressure of the gas, and rho will be density of that gas. This is Laplace's correction. And if you put the values here at normal temperature and pressure, if you put pressure equal to 1 atmosphere, 1.013 into 10 raised to 5, rho 1.29, gamma 1.41. हे व्हॅल्यूज जर टाकले तर वेलॉसिटी येते 332 मीटर पर सेकंड, म्हणजे एक्झॅक्ट व्हॅल्यूच्या खूप जवळ येते. कारण एक्झॅक्ट व्हॅल्यू आहे 332.2 समथिंग. तर एक्झॅक्ट व्हॅल्यूच्या खूप जवळ येते. मीन्स दिस फॉर्म्युला इज मोर करेक्ट. Newton's formula had an error. It was corrected by Laplace. So this formula is more correct. V is equal to under root gamma p by